Okay, today we want to look at finding antiderivatives of functions that involve trig functions. So just like yesterday, what did we do yesterday to figure out the process of integration?
Add one.
Yeah, but what did we do to figure out we needed to add one and then divide by it?
You took the derivative and then
We took the derivative and then what did we do? We did the opposite of it. So that's what we want to do to get started today, is we want to remember our derivatives of our trig functions. So what's the derivative of sine? Cosine. Derivative of cosine?
Negative sine.
Negative sine. Derivative of tangent? Secant squared. Cotangent?
Negative secant squared.
Negative cosecant squared. Derivative of cosecant?
Secant.
Negative cosecant cotangent. And the derivative of secant? Secant and tangent. So now that we have those, we should be able to go to the right side and integrate on the right side. So what is the integral of sine going to be?
Cosine squared.
Negative cosine.
That doesn't work how I thought it would.
Don't forget about the c, the plus c.
You don't just go back. What is the next one?
I've got to find, if I'm integrating, then I need to find what's on the right, and it turns into what's on the left. So since I'm integrating sine, I've got to go find sine on the right, and it turns into what's on the left. So all I really need to do is kick the negative over, so that means if I integrate sine, it gives me a negative cosine.
Okay, so that's going to be sine.
So the next one's going to be sine, because if I'm going to integrate cosine, I go find cosine here. The other side of cosine is sine, so that would be sine of x plus c. So what do I get for secant squared?
Tangent.
Tangent. Cosecant squared?
Negative cotangent.
Negative cotangent. Cosecant cotangent?
Negative cos.
Negative cosecant. And secant tangent.
Secant.
Secant. So if you forget how to integrate any of these, what should you do if you forget?
Take the derivative.
You should go back over, take the derivatives, and that will help you remember how to integrate. Alright, so let's do a few problems that involve them. Alright, first example is I want to integrate t squared minus sine of t dt. So what do I get when I integrate t squared?
T cubed over 3.
T cubed over 3. And what do I get when I integrate sine? Negative cosine. Now, I want to mention something real quick before we move on. So we end up with t cubed over 3 plus cosine t plus c. Now, when we were finding derivatives, when we take derivatives, how did we know whether or not the derivative was going to end up being negative or positive? If it started with a c. If I took the derivative of something and it started with a c, it would end up being a negative answer. Okay? Now, how do I do that if I'm integrating? What's going to tell me whether or not when I integrate whether or not it doesn't start with a c?
If it starts with a code, it's positive?
No.
If
Now think about it. Integration is the opposite of derivative. So if I started with a c and I ended up with a negative,
you end with a C.
if I end with a c, it's got to be negative. So when you integrate a trig function and you end up with a trig function that starts with a c, it has to be negative. So if you go through there and look on that right side, everything I ended up with that ended up with a c has a negative in front of it.
No, secant squared.
Secant squared doesn't have a negative in front of it.
I thought you said it does.
On the right side,
Like he's saying, not like the
on the other side of the equal sign.
He's saying like whenever you take the,
What?
whenever you integrate it, it has to start with C. Not like secant into C.
I'm saying everything over here, there's a C, it's got a negative. There's a C, it's got a negative. There's a C, it's got a negative. These right here don't have C, so they're positive.
You said end in C.
That's what I mean. What I mean by is end is the trig function I end up with after I integrate.
Oh.
So these are the trig functions I end up with. No, not the last letter. The trig function I get after I integrate is what I'm saying. So in this case, I know sine goes with cosine, and then I need to decide whether or not it needs to be positive. I know it has to be negative because I ended up with a trig function that started with a C. That's what you do. Next one. All right, I have secant y times tangent y minus secant y dy.
Distribute.
Distribute. Now, let's talk about what tells me I need to distribute. A couple things tell me that.
You don't know secant.
The parentheses.
I don't know how to integrate secant by itself. Okay? If it's not one of these, I can't integrate it right now. So if it's not one of those, that tells me I've got to do something. And one of those somethings I might need to do is what I need to do here, and that is distribute. Okay? So if I distribute, I get secant y, tangent y, minus secant squared y, dy. What were you going to say here?
Did you tell the other reason why you have to distribute? Did you say that?
Well, it just looks like it's asking to be distributed to me. That's the other one, I guess.
It just looks like it's asking for it.
Yes, it is. It's asking for it. All right, once I get here, then we should be able to integrate secant tangent and turn it into secant.
Plain city.
And then we should be able to integrate secant squared and turn it into tangent. And don't forget about the plus c. So when I integrate that, I get secant minus tangent plus c. All right, next one. I have the integral of cosine over 1 minus cosine squared. What?
You do the same thing as yesterday. You have to put cosine
You can solve all
If it was switched, yes. If you've got a polynomial on the bottom, you don't want to separate it. You only want to separate it if you have the monomial on the bottom.
No, I don't know what to do.
So, do I know how to integrate cosine squared?
No.
No, so that tells me I've got to do something.
Take out a cosine.
I don't want to take out a cosine.
Wait, isn't
Change it to,
Oh, that's one of
Sorry.
your special things.
yes, we got to remember
Sine
last
squared.
week, sine squared.
Good job, team.
So we're going to change 1 minus cosine squared to sine squared. Yes.
Isn't
if you
that a
don't
difference of 2 squares? You separate like that.
You could, but it's not going to get you anywhere.
Then you have to change it.
Remember, if it's something squared and you're adding or subtracting a 1, usually you want to turn it into a Pythagorean identity.
Yeah, what if we don't remember those?
You don't know how to do sine squared.
All right, now let's do. What do you want to do now?
Separate it.
Separate it.
Cosine over sine, and then 1 over sine.
Very good. Outstanding, Samantha.
New Year's thing,
So separate it into cosine over sine and 1 over sine. Because now that cosine over sine can turn into cotangent. And that 1 over sine turns into cosecant.
Why don't you just do cosine over sine times sine?
Because the signs are in the bottom.
Huh?
The signs are in the bottom. If I do cosine over sine times sine, that's telling me that the second sign would be in the numerator.
No. Sine times sine, both on the bottom. And then you do the antiderivative of both of those.
No, can't do that.
There'll be 2 negative cosines.
Can't do it. You can't do it if they're being multiplied or divided. You can only do it if it looks exactly like what's on your sheet that we wrote down on the top. If it doesn't look exactly like that, then you can't do it.
Sometimes it's
So now, what's the integral of cotangent times cosecant? It's cosecant, but I know it has to be negative. Why do I know it has to be negative? Because I ended up with something that started with a C.
Plus C.
And don't forget about the plus C.
Why don't matter? Is it alright if this is really confusing?
1 over sine base turns into cosecant.
Yes.
What is 1 over cosine?
Secant. All right, then we want to get into solving differential equations, which we've looked at before, except now they're giving me a little bit more information. They're giving me a little bit more information because now I'm going to be able to figure out what C is. Okay? So I have dy over dx equals 2 times x minus 1, and then they're telling me the initial condition is 3, 2. Okay, we'll get to that initial condition later. But what do I want to do to solve dy over dx equals 2 times x minus 1? Move the dx over and distribute the 2. So dy equals 2x minus 2 dx. Then what do I want to do?
Plug in. S.
Integrate. So if I integrate dy, I get y. Okay, the 2x, what's my new exponent? 2, and I need to divide by the 2. On the 2, what do? Add the x. Don't forget about the plus c. Alright, so clean that up a little bit. I have y equals x squared minus 2x plus c. And now this is where the initial condition comes in too.
Plug in.
I plug in. So I'm going to plug 3 in for x and I'm going to plug 2 in for y. So I have 2 equals 9 minus 6 plus c. 2 equals 3 plus c. So that means my c is negative 1. So I plug that negative 1 back in to replace the c. There's my solution. Now, what do I know about that solution? Very good. It is the antiderivative of 2 times x minus 1. Okay, and what else do I know about it?
It's the same as the original.
You can take the derivative of that and do it.
The derivative of that equals that, but that's the same thing as
Yeah.
saying it's the antiderivative. What else do I know? What do I know about
It's
that
at
point?
0.32.
What about the point 32? What do I know about the point 32?
Is that the tangent line?
Secant line. Secant line.
Slope.
Cosecant
Where
line.
Let me start.
Cosine line.
Since I did it that way, that means if I were to graph that function would have to go through the point 32.
That
Okay.
was
It's way more basic.
So if I graph that, it goes through the point 32. Let's look at one more of those.
Looks fancy.
Alright, g prime of x equals negative 1 over x squared, and my initial condition is 1, 3.
Move it to the top.
Move it to the top. Gives me that. Then what?
Add 1.
You add 1 and divide by.
So I want to integrate, which means there really needs to be a dx here. What do I get when I integrate g prime of x? I get g of x. So over here, I need to add 1, which makes it negative 1, and I divide by it. And don't forget about the plus c. So clean that up a little bit. I have g of x equals 1 over x plus c.
And then you
And then I plug in. So I have 3 equals 1 plus c. So that means c equals 2. And I plug that back in, so I get g of x equals 1 over x plus 2. So what two things do I know about g of x equals 1 over x plus 2?
Antiderivative.
It's the antiderivative of negative 1 over x squared
Crossing through.
Right.
and it goes to the 0.13. And I'll show you that it goes to the 0.13.
It's good to know. Five, six, seven, go, 3.
All right, so here's my function 1 over x plus 2. I plugged in the point and plugged in my x value of 1, and it produced about the y value of 3. So here's my function, and this shows you that it does go through the 0.13. All right, so when you're integrating and it involves a trig function, and what you're integrating is not one of these 6 over here on the right, what needs to be done? I need to maybe use a Pythagorean theorem, what else? Or Pythagorean identity, what else? I may need to distribute, change it into, and so what are those identities called? Anybody remember what those identities are called? What'd you say? Quotient, and what's the other one?
Product.
Starts with an R.
Reciprocal.
Reciprocal identity. Okay. So if it's not one of those, I might need to multiply. I might need to use a Pythagorean identity, a quotient identity, or a reciprocal identity.
What's the